In order to know about the Karlsruhe multiplication, we must know what is recursive algorithm. So in this, we will see what is recursive algorithm. So if we have one digit, let's say x, and we want to get the power of that digit, what we will do, we will simply multiply that digit with that power. So we have, if we want to calculate that digit, then we have to do the calculations that is added as a power. So it will become a very large digit. So in the recursive algorithm, the approach is that we divide that figure into half, and the answer that we got is further divided into half. And this recursive process is continued until we get the answer 1. So we will see the example of this recursive algorithm. So for example, we want to have this figure x raised to the power 18. So one method is that we compute this x raised to the power 18. So it will take a very long time. So the recursive approach is that we divide this into two parts, x raised to the power 9 times x raised to the power 9. So we divided it into two parts, x9 and x9. And now it will be much easier to get the answer. What we will do is we compute x9 and then we will multiply the answer with the same x9. So it will save time and much of the steps involved in this one. So what we are doing is we are reducing it to the factor of 1 by 2. Hence we have 18 multiplications, and now in this case we have only 9. If we kept on doing this in a recursive manner, we get x4. For example, if we divide this one, and we here has x9, and we divide x9 into two parts divided by 2, we got x4 times x4. Because 4 and 4 is 8, and here we have power of 9, we will add 1x. So it will become x9. So if we have the even integer like 18, so we can divide it into equal two parts. So in case of odd number integer, we cannot divide it equally into two parts. So we will adopt this strategy. So we add 1x at the end to balance this equation. So what we have done here is we have done this 9 by 2. 9 by 2. So we had divided it, this 9, into two equal halves. If we kept on doing this recursive methodology, what we will get is we will further divide x4 into two parts, because now x is an even integer, 4 is an even integer. We can divide it into equal two halves. So again, the strategy is same. Here it is 4 by 2, and here it is 4 by 2. So we divide it into equal two parts, and further we can divide the x2 into two equal parts, x into x, and again the strategy is to divide it in by 2, and we will get the x. We can further divide in the recursive manner the x, and we will get x naught and x naught and the x. So what we have achieved is we have produced from the time complexity that is proportional to n to one that is proportional to log n base. We have got this one, log n base 2. We have got this one. So this algorithm, that is base case, and if n is 0, then x not relative is returned to 1. So this is repression step. Here we calling the function once more. This time exponent is half, means n by 2. As we saw above, it was 18 and we halved it to 9, and we had divided further and until we got the answer 1. So in this recursive algorithm, we can got the very small numbers of digits, and ultimately we reach to this log 2n, because log 2n, for log 2n we have to multiply less times as compared to log n. So in the recursive algorithm approach, we can save a lot of time in the terms of many steps.